Okay, so in calculus, right, often you will be given two functions, just random functions, and you need to be able to graph them quickly but accurately and then find their points of intersection. Because as you see here, right, these two functions intersect, here and here, right? And then do you see how in between the two functions you have this enclosed area, right? So often in calculus what you would need to do is you would need to find, let's say, the area of that region. All right? To do that, you first need the the coordinate points. Now, I'm just gonna, okay, so let's just talk about a couple of things, right? At the coordinate points, so here we have 2x plus 1 and x squared minus 2. At the points of intersection, right? So here, the x, so this is what? This is x equals what? 3 and y equals 7. So at that point, right, both functions have the same value, right? So the x and y coordinates are equal at that point, right? So for the parabola, when x is 3, y is 7. For the line, when x is 3, y is 7. And same with this one, minus 1, minus 1. All right, so that's important that since the x and y values are the same, right, we can find the points manually and by using a calculator. Okay, so here we go. Let's plug these in the calculator very quickly. This first set of functions. So I get, I actually, okay. So go ahead and take out your calculators. So here we're going to get x cubed plus 3. Oh, what did it throw? Right? And then also x squared plus 7. Okay. So since that's x squared plus 7, right, we know the point of intersection is going to be like way up high. So maybe let's get this up to 15, right? Right there. Okay, so go ahead and find that point of intersection for me, please. So that's 2 comma 11. Okay, let's go ahead and do the next one here. All right, so here you can solve this one for y to plug it in here. But you know what? I'm just going to press doc B here for a minute and go back to your graph. I want to put them in as a relation. So why don't we go to menu? Number 3 is graph entry. And I want a relation number 2. So now I can literally type in x equals 3y. But you know what? I'm going to change that. I'm going to make it minus 2, not plus 2. I'm going to make this a minus. Okay, and then enter, right? So then I'm going to press tab and enter the other one, y equals half x squared, or I'll make it 0.5 x squared. So once you make it a relation, you have to enter both x and y, right? So you can see that there is a point of intersection there. Okay, so here's what I'm going to do. First, I want to move these labels away because they're just getting in the way. So now I want to find the point of intersection, and it's a little bit of a different process here. When you go to analyze graph intersection, it asks you first corner. So literally drag this anywhere here in the white space, click, and then drag, right? You're not going to be like, it's not going to be just a vertical line. It's going to be a whole region because it's a relation. So drag just so you can include that first point. Okay? Okay? So it is negative 0.869, 0.377. Okay. And then go ahead and find the other one as well, but don't call out the answer just yet. And you can go in any direction, right? It doesn't just have to be up. And try to get, I don't know why I'm not getting more decimal places here. Okay. What did you guys get for the second one?
1.535, 1.178.
Okay, for some reason it won't let me increase my, I don't know. Okay, I don't know what's going on. So what is it? 1.5?
1.178.
Okay. Cool. All right. Now, to do the same thing manually, right? If you're not given a calculator, then we know that at that point, the x values are the same and the y values are the same, right? So you can either set the x's equal to each other and solve, or you can set the y's equal to each other and solve, right? To do that, you have to solve both equations for either x or y. All right, so let's take a look at this one. Both of these are solved for y, right? So this is y equals x squared minus 2. This is y equals 2x plus 1. At the point of intersection, since the y values are the same, we can set whatever y is equal to each other, right? So then it just becomes an algebraic equation that we need to solve. X minus 3, x plus 1. So x equals 3, negative 1. Okay, now I need to get the y values of this. To get the y values, you're going to take each of these, and because at the point they both have the same value, it doesn't matter which one you plug it into. At that point, they are identical, like they're the same. So I'm just going to plug it into the linear function. 2 times 3 plus 1, what does that give you? 7. So one point is 3 comma 7, and then the other one, how much is that? Negative 1? Right? So those are the points of intersection. Cool? Yeah, because they give you the same value, right? Because they're the same by definition. Okay. Right? So if you wanted to find the area of the region enclosed between those two graphs, you couldn't do anything if you didn't have those points. All right? Okay, so this next one is a little bit of a different situation, right? So we're gonna like work smart, not hard for this one. All right. So here you have y equals 6. Here you have x equals whatever. This one is just a horizontal line. So y equals 6 all the time. It's just x that's changing. So yeah, you can potentially solve this one for y, right? If you square both sides, right? And then you can set x squared plus 2 equal to 6. Or we know that y is going to be 6 always. We just need an x value. So I can just plug 6 into here. Right? So the coordinate where they intersect is 2 comma 6. All right? Questions? Okay. All right, so let's review graphing functions, obviously without a calculator. X squared minus 4, everybody's favorite parabola, vertical shift of 4. And we have, okay, so the point is you have to be able to do it like quick on your feet. So up over 1, up 1, over 2, up 4. Okay. And Here we go. And then it says to identify the x or the y intercepts, right? You should be able to do that using the function, and usually that will also guide you on how to graph this, right? So for the x-intercept, okay, we're going to do x squared minus 4 is equal to 0. X is plus or minus 2. Now, henceforth, we are always going to provide or any intercept in coordinate form, right? So this is going to be 2, 0, negative 2, 0. Ugh, that doesn't work. Okay? And then for the y-intercept, it's just y of 0, and that's negative 4, so 0, negative 4. Yes? Okay, so here we go. For this one, x-intercept, x cubed plus 1 equals 0, x is minus 1. That's how quick it should be. Y-intercept is 1, right? So y-intercept is 1, x-intercept is negative 1, and then we know that this is how this looks, right? If you go over 1, you go up 1. If you go over 2, how much do you go up? 8. Correct. Okay? Right? Right. Okay. All right, negative x minus 5. Okay, so let's do x-intercept first. So negative root x is equal to 5. Root x is negative 5, so there is no x-intercept, right? Yes? Because you can't have a root equal to a negative number. But what's the y-intercept? Yep. So 0, negative 5. Okay, all right, so to graph this, okay, so we know there is a vertical shift of negative 5, right? So here we go, that's the y-intercept. And then if I go over 1, I go down 1. If I go over 4, I go down 2. Right? Clearly, no x-intercept. Okay, this one. So this one is y squared, not x squared. Right? Now I need to find x-intercept, y-intercept. Okay. Remember, okay, so there's like so much we could do here. Okay? First of all, remember how else we've learned to find x-intercept and y-intercept. To find x-intercept, what has to be 0? The y has to be 0. So x equals 0 minus 2, negative 2. Y-intercept, x has to be 0. So y squared equals 2. Y is plus or minus root 2. Right? Now, I want to graph this guy. Right? Why don't I solve it for y before I graph it? Because I know how to do that. So here we get y squared is equal to x plus 2. Y is, when I take a square root, y is what? Just root x plus 2? Plus or minus root x plus 2. Okay, so that means I have a horizontal shift of negative 2. Okay. Now, over 1, up 1. And look, my y-intercepts, right, they're root 2 and negative root 2, so somewhere between 1 and 2. But also, if I go over 4, I go up 2. And same thing here. Right, and the y-intercepts are somewhere in the middle there. Okay? Right? So it's just like a parabola. It's a sideways parabola. And there is a shift of -2. This, when we bring it over, right, the -2, when it comes over, it affects the x. We'll go over this again in a little bit. But so there is a left translation to the left. Okay.
Wait,
Yeah, go.
how does the plus minus affect it?
So it'll be y squared. It'll be y squared equals x plus 2, right?
Mhm.
So this, it moves it that way.
The plus minus does?
Yeah. Because it's affecting the x, right? It's affecting the x. So if it was y plus 5 squared, then that would have been a vertical shift.
So you basically, it's like the only thing that matters if it's a plus minus is just the minus.
Yeah. Okay, you guys remember how to graph a sine function over one period? Yes, let's do it. Yeah, how much is that? What's the period? 2 pi. Pi Day is coming.
No, that's my birthday.
Oh,
Yeah, and it was the day Albert Einstein was born.
yes, it was. Huh?
Which I think is really ironic.
I know, right?
Friday.
I know.
No, it's 3.14. So that's, it has nothing to do with Albert Einstein. No, it's okay.
Okay.
So basically, I'm just like the coolest, right, Miss Lily?
It's the ratio
On
between
Friday, right?
the circumference to the diameter of any circle.
It's the way that
Take
I
any
look at
circle, any circle. The circumference divided by the diameter is always 22 over 7 pi. I know.
Miss Lily, I'm just
Any
like,
circle.
really-
Even like in like Japan or France or like Nicaragua. I know, right? Even in like Antarctica where you have like frozen circles. Still, circumference over diameter, pi.
Wait, but you said even in
But Miss
Nicaragua?
Lily, you're not
Even in
answering my
Nicaragua,
question.
even in Nicaragua, a politically unstable country, and yet the one thing you can count on, man, is circumference over diameter is pi, huh? Oh, a circle is always stable. It is the most stable shape out there. Stable. It does roll. It does roll. It rolls. And you just gotta roll with it. You just gotta roll with it. Triangles, are they?
Wait, Miss Lily,
What
am
is
I,
your
like, the coolest
question?
person you've ever met?
Yes, absolutely. Hands, oh yeah, hands down. Yeah.
Miss Leakey, you know where I learned that triangles are the most stable shape? Guess, just take a wild guess.
What? What did you
The
ask?
Boss Baby movie. In the first 10 seconds of the movie, they're like, where there are people in the family, and that makes a triangle, and you know a triangle is the most stable shape.
Oh.
Because it's very, like, I don't know, that's like where I learned triangles are the most stable shape.
Okay. Fabulous. Maybe we should watch that.
It was like, not.
We'll watch it on Friday, no? Okay.
Oh, yeah.
You know who else was? And Stephen Hawking died on Friday.
Oh. Steph Curry. Okay, now you just ruined it.
I'm just like,
Curry have to do with Friday?
Okay.
Wait, you say LeBron?
Oh, because of the.
I'm graphing a cosine.
Barack Obama. Isn't it weird that Albert Einstein and Stephen Hawking have like a relationship?
Even more famously born on my birthday.
Okay.
Yeah.
Who? For this one, we're gonna find the points of intersection using a calculator. These two, by the way, these graphs, I've actually taken them from like one of the like AP Calc questions, or I don't know, somewhere a long time ago. So let's just do that. Again, in calculus, any level of calculus, you would be given these two, and then you have to find the area in between, right? And there is no way to do it. Like you could do it manually, right? Finding the area, but there is no way to do it if you don't know the intersection points. So I'm just gonna doc
You have to
B
put it in
this.
radians, right?
Absolutely. Make sure your calculator's in radian. That's why we're doing this actually, because I know you all know how to put this in your calculator and get a point of intersection. But if you have it in radian, this is what it looks like. If you don't have it in radian, then you got nothing to work with. And then once you get past, okay, so once you get past, like, pre-calc, whatever, like in math, upper level math, it's always radian, right? The degrees come in like for engineering and such, because then we're applying. So here we get x squared minus 1, and I just want to show you, right? If let's say I go to menu, analyze graph, Windows Zoom, and you know what I want to do? I want to make this like 3/4 of a pi, so 0.75 pi.
Why would you do it?
Because just go with me. Don't judge me, because it's pretty.
Oh, because it's definitely gonna look like what the thing looks like on paper. I'm predicting it. You heard it.
Oh, because this is supposed to be the minimum and this is supposed to be the maximum. Right?
That looks exactly like
Yeah,
the graph.
similar. Okay, so, and then you could go ahead and find the 0.7 intersection. So why don't you guys go ahead and do that? Up to 3 decimal places. Correct, because these are, okay, because what type of function is a cosine? Is it odd, even, or neither?
It's even.
It's an even function, which means it's symmetric around what?
The x-axis.
The y-axis. And what about x squared minus 1, even or odd?
What? Say it again.
X squared minus 1, even or odd? Even. Because, so that's also symmetric with respect to the y-axis. So you are going to get 2 symmetric points. Okay, so what was the point of intersection? One of them?
Negative 1.265, 0.601. And then just like.
Fabulous. Okay.
I still can't get my calculator and radian.
Just click where it says degrees in the top right.
Okay. This next one, we're not going to do it because you all know how to do it. Okay, I don't need to waste time with it.
Wait, how do you know that a cosine's always gonna be positive?
Wait, but it looks so cool.
Yeah.
Wait, but how do you know cosine's always gonna be positive?
We did that in one of our things. We proved that it was even.
When?
In one of our tests.
Okay. Shh. You have to find f of negative x. If that is the same as f of x, then it's even. If f of negative x is negative f of x, it's odd. Otherwise, it's neither. Okay. There you go. There you go. Okay. So now, okay.
We're still moving on.
Yep. Okay. So let's talk about semicircles. It's our favorite. So back in the day in geometry, you learned that the equation of a circle is x squared plus y squared equals r squared. So for example, if you have x squared plus y squared equals 9, that would have given you a circle with a radius of 3. Okay? Now, let's solve this equation for y. So we would get y squared is r squared over x squared. Then when you take a square root, y is, right, when we take a square root, y is plus or minus the square root of r squared minus x squared. So just like when we get plus or minus a root, right, we have 2 equations essentially, right? The positive one graphs, a square root on top. The negative one is the reflection on the bottom. Here too, the positive one gives you a circle above the y-axis, a positive circle above the x-axis, and this one gives you a circle below, right? So each of these is an equation of a semicircle. Together, the plus or minus is the equation of a circle.
And that's how you graph a circle.
Okay, so now, we need to be at a point where, like, this is one of those, like, billboard problems. You're walking down the street, you see a billboard, and there is an equation, y equals the square root of a number, a constant minus x squared, not plus, minus x squared. You know immediately that's a semicircle, right? So if I were to see this 16 minus x squared in the square root. I know that's a semicircle with a radius of 4. So to graph that semicircle, right, it's a radius of 4. And because it's positive, it's above the x-axis. That will look like this. Okay? So semicircle with a radius of 4. Okay, so that now that you, okay, so when it comes to like learning this, right? When you're told once, then it's kind of like expected that you will know it for the rest of your life. Okay? So the square root of a constant minus x squared. Yeah.
How is that any different from our other square root functions?
Well, because until now it was like x minus 3, let's say, not x squared. But now, please be careful about this, right? So when I graph, where is it? When I graph this, right, if I do the square root of 16 minus x squared, semicircle, okay? However, if I do x squared minus 16, it's a whole different thing, right? So it is not like, oh, my bad. No. It's a very different thing, okay? All right. So, okay, so here we go. Let's do this very quickly. Okay, so x equals half y squared minus 3. We're going to find the intersections without a calculator. Okay, so you know what I'm going to do? Actually, before I graph them, I'm going to find their points of intersection, right? So look, both of these are solved for x. So why don't we set those x's equal to each other? So now let's bring everything to the same side. And who likes that half there? Anybody? I don't. So we're going to multiply everything by 2. So I get y squared minus 2y minus 8 is equal to 0. Oh, look at that. That's y minus 4, y plus 2. So y equals 4 and negative 2. To get the x values, I'm going to plug it in whatever is easier, right? X equals y plus 1, 5. So 4 comma 5. And then negative 2 plus 1, negative 1. So that's, oh no, it's 5 comma 4. Sorry. 5 comma 4 and negative 1, negative 2. So look at what I do. I go to 5 comma 4 and I know there's going to be a point of intersection, and negative 1, negative 2, there's going to be another point of intersection, right? Now, let's graph these. X equals y plus 1 is the same as y equals x minus 1, right? So I just graph that. Ugh, I don't know what the heck is going on here. I really need to fix this situation. Okay? Now, this one, I also want to solve for y. So half y squared is equal to x plus 3. Y squared is 2x plus 6. So y is plus or minus the square root of 2x plus 6. Are we okay with this so far? Okay. Now, we're going to graph this, 2 square roots. Now, let's talk about the shift. Okay, there's a plus 6, but there's also a coefficient of 2 for the x. That means there is like all sorts of things happening. There's also a horizontal dilation. So to figure out what the shift is, you have to take this, set it equal to 0, so x is negative 3. Right? That's not any different than what we would do if you had like y equals root x plus 5. How do you know it's a left shift of 5? Because x plus 5 equals 0, x equals negative 5. So, negative 3. Okay? And then, so then, you know what? Maybe I think I want to plug in some points here. So let's see. What can I plug in to get a, maybe -1? If I plug in -1, I get -2 plus 6, 4. Root 4 is 2, right? Yeah. Yeah. And then I know there is another point over here, right? Because that's going to be a point of intersection up there. So I'm just going to go this way, and then I can mirror it here. Right? Isn't that beautiful? Oh. So depending on what the reason is for why you're doing this, okay? If, let's say, it is calculus and you're doing it for the points of intersection, you know, you really care to get, you know, those points accurate, and then this one may or may not be. You know what I mean? Okay, let's do this next one as well. So how does that look? What's this one gonna be? What shape? Is it? Semicircle needs a...
No, because it's not a square.
Right.
No, a square root.
So where would the square root come from?
No, it doesn't. Well, I'm thinking that you're squaring the one.
Alan said parabola. You said parabola. I feel like we got something here. Yeah, right? Okay, this is like your favorite parabola of all time because it's just written in a different way. So this is y equals plus 2 minus x squared. But if I wrote it in reverse order, minus x squared plus 2, now we have no question about it, do we? Right? So there we go. Okay? Yep. So go ahead and graph that here. And yeah. So y equals negative x, right? So let's see. 2 minus x squared is equal to negative x. So let's solve this. X minus 2. No, does this? This doesn't. Does it factor?
No, it's
That's minus 2. No one, oh my God. I knew it was supposed to factor. Okay. So like this. So x equals 2, x equals negative 1. So y equals negative 2, y equals 1. All right, so 2, negative 2, negative 1, 1. Okay. So here's 1. Okay. And there's the other one. So the x-intercepts for the parabola, right, what are they? Yeah, x squared plus x squared equals 2. So x is plus or minus root 2. So they're like here about, right? So that's how this is going to look. Right? Okay, all right. So this is where we'll stop for today.